Hello children, today I am going to discuss with you another measure of dispersion. This is the second measure of dispersion. First was range, which you have already understood. Now we come to the second measure of dispersion, that is quartile deviation, or it is also known as semi-interquartile range. So this is second measure of dispersion. Range, as you have done earlier, range considers only the extreme values, extreme lowest and extreme highest, right? So it considers only the lowest and the highest values and eliminates the central values, whereas quartile deviation, it eliminates the lowest 25% and the highest 25% of items of series. It is eliminating the lowest 25 and highest 25% of the series, and what it is considering, only the central 50% of the values of the series. So it is different from range. So only central 50% of items are considered. So this quartile deviation considers only 50% of central values, eliminating 25 lower values and 25% of upper values. QD, that is quartile deviation, is the difference between upper quartile and lower quartile divided by 2. You have done quartiles, that means dividing the series into 4 equal parts, and accordingly we have Q1, Q2 and Q3. What is quartile deviation? That is the difference between upper quartile and lower quartile. Upper quartile is Q3, lower quartile is Q1. The difference between the two divided by 2 is known as quartile deviation. Interquartile range is Q3 minus Q1, that is range of the quartiles is Q3 minus Q1. Q3 is the upper quartile, Q1 is the lower quartile. So the range is Q3 minus Q1, the difference between Q3 and Q1. And semi-interquartile range is Q3 minus Q1 upon 2. This is also known as quartile deviation. Q3 minus Q1, this was Q3 minus Q1 only, interquartile range, and semi-interquartile range is Q3 minus Q1 upon 2, right. So now we will take the calculation of quartile deviation in different series. Now what are the steps for calculation? Calculate Q1 and Q3. So as quartile deviation is the difference between Q1 and Q3, or you can say Q3 minus Q1. So you have to calculate Q1 and Q3 first. For calculating quartile deviation, find out the value of Q1 and Q3. This you know because you have done it in the previous chapter also. Subtract Q1 and Q3, subtract Q3 and Q1. You know Q3 is higher, so Q3 minus Q1, and divide the result by 2, right. So Q3 minus Q1 upon 2, this you have to calculate. Coefficient of quartile deviation is Q3 minus Q1 upon Q3 plus Q1. This is the relative value, coefficient, relative measure, coefficient of quartile deviation. Okay. Now we will take the calculation in different type of series. First we will take individual series. Marks are given like this. These are individual items. How do we solve Q1 and Q3? Q1 is size of n plus 1 upon 4th item. You know the formula for Q1 in the individual series is n plus 1 upon 4th item. And what is n? Total number of items given over here. 1, 2, 3, 4, 5, 6, 7. So n here is 7. 7 plus 1 upon 4th item that is second item. Now second item in this series is, this is first and this is second item, so Q1 is 25, right. So this way you calculate Q1 in individual series. Now Q3, size of 3n plus 1 upon 4th item, that is equal to 3 into 8 upon 4, 3 into 8 upon 4 means 24 upon 4 equal to 6th item, and that is equal to 65. 1, 2, 3, 4, 5, 6th item, and that is 65, right. Now QD is Q3 minus Q1 upon 2 is equal to, Q3 is 65, Q1 is 25, so 65 minus 25 upon 2 is equal to 40 upon 2 is equal to 20. This is QD. QD is 20. Very simple. Q3 minus Q1. Q3 you have calculated, Q1 you have calculated as 25 and 65. 65 minus 25 upon 2 you will get 20. This is QD. Coefficient of QD is Q3 minus Q1 upon Q3 plus Q1. This is a relative measure. Here put the values, Q3 is 65, Q1 is 25, 65 plus 25, 40 upon 90, and this is QD, coefficient of QD. This is QD and this is coefficient of QD, right. Now discrete series. This is the simple calculation of individual series. Remember the formula what you have to apply for individual series. Now we will take the calculation in discrete series, right. Discrete series, you know well, it has the frequency. So X column and F column, these are the values for X column, these are the values for F column, frequency given. Now for solving or for finding out Q1 and Q3, you have to make 3 columns. First column you will write down X in the same order, copy down, frequency copy down in the same order, find out CF, right, by adding up the frequencies. Now after completing this part, we move to Q1. In the discrete series also Q1 is n plus 1 upon 4th item. Here n is 69, this is n given 69, total of frequency, number of items. So 69 plus 1 upon 4, that is 70 upon 4 is equal to 17.5th item. Now 17.5 is not Q1, it is 17.5th item. Now where is 17.5th item? It is here. This is 20. Inside this figure we have 17.5th item value, and in front of this, this is Q1, right. Similarly Q3, 3 n plus 1 upon 4th item, 3 into 70 upon 4th item, 210 upon 4, 52.5th item. Now 52.5th item in this series is here, right, and in front of this we have this as Q3. Clear? So Q1 and Q3 you are going to calculate in this manner. After calculation, calculate QD. QD is Q3 minus Q1 upon 2. Q3 you have got 53, Q1 is 35, put the values, divided by 2, 18 upon 2, and QD is 9. So simple, very simple to calculate. Enough practice you have done in the case of quartiles. You know how to calculate quartiles, that is Q1 and Q3, and QD is just Q3 minus Q1 upon 2, the same. First you have to calculate this and then put the values and get the answer. Now coefficient of QD, Q3 minus Q1 upon Q3 plus Q1, 53 minus 35 upon 53 plus 35, 18 upon 88, and this will give you coefficient of QD. Just main thing is you learn the formula, you know how to put the values at a proper place. There is no chance of any error and the calculation becomes simpler. Okay. Now after discrete series, now we will move to calculation in the case of continuous series. In the continuous series, we have the class interval along with the frequencies. Class interval is given here and frequency is given. Class is here in the same order, you will copy down in the first column. Frequency write down here in the same order. Calculate CF, right? Wherever frequency is given, you have to calculate CF. Now again the same formula for Q1 and Q3 as you have done in the case of quartiles. N upon 4th you have to find out. Total of frequency is 40, right? So N is 40, 40 upon 4th is 10th item. Now 10th item is here, N upon 4 is 10. So 10th item is here lying in this category, N upon 4 is here. Now L1 is lower class interval in front of this, CF is preceding frequency, F is this one as you have done earlier. So L1 is 10, N upon 4 is 10, CF is 2 and F is 8. Class interval is interval of this class, that is 10. Simplify it and Q1 is 20, right? Q3 L1 plus 3n upon 4 minus CF upon F into I. Now 3n upon 4. What is 3n upon 4? Here 3n upon 4, 3 into 40 upon 4 is equal to 120 upon 4, that is equal to 30. So here 3n upon 4 is 30 and in this series find out 30. Here this is L1, this is CF and this is F. 30 minus 21 upon 9, 40 is the lower class limit, 10 is the class interval, simplify it and Q3 is 20 or 50. Clear? Now after calculating Q1 and Q3, QD is Q3 minus Q1 upon 2, this is 50 minus 20 upon 2, this is 30 upon 2, that is 15. So QD is 15, coefficient is Q3 minus Q1 upon Q3 plus Q1, 50 minus 20 upon 50 plus 20 and this is QD, coefficient of QD. So very simple, right? So in this way you have done calculation of quartile deviation in 3 type of series: individual, discrete and continuous, right? Now we have to see what are the merits and demerits of quartile deviation. Here merits: first, easy to calculate and understand. As you have done now, it is very easy to calculate and easy to understand. Second, it is used to measure variation in open-ended distribution. In open-ended distribution, open-end classes, this type of deviation or this measure of dispersion can be used. Can you tell why? Because we are ignoring 25% lower limits and 25% upper limits. We are taking only central values. So in the case of open-end classes, it hardly matters because we are not concerned with lower limit and upper limit. So, in this way this is considered good in open ended distribution. Third, not affected by extreme values. Extreme values we are ignoring, we are taking the central values, so it is not affected by extreme values. This is another merit of quartile deviation. Now, demerits: ignores 50% of items of series, that is first 25% and last 25%, right. One way it is good that we are taking the central values and we are not concerned with the extreme values, it is a merit, but we are not considering the whole of series. 50% series is, you can say, neglected, it is not taken into consideration, only 50% is taken into consideration, so this is a demerit. Second, does not show complete formation of the series, because it is concentrated only in the central value, so it does not show the complete formation of the series. And third demerit, method is not much in use, because it is ignoring 50% of values of the series, so this is not used widely in the calculation of statistics. Though it is not, it cannot be avoided, you can say, it is not a waste, you can say, but it is not frequently used in statistics, but it is still of use when we are concentrating only in the central value, or when they are open end distribution, then it is of some use, right. So, this way you have done another measure of dispersion, that is quartile deviation, and next you will be moving to, you know what, that is mean deviation. That is a better measure of dispersion in comparison to quartile deviation, that we will take next time. Till then, okay, goodbye.